right, let's go ahead and try to tackle these problems one by one. The first one we're going to look at is this one here. Y is equal to negative 3 plus 2 sine 2 times the quantity theta plus pi over 4. So let's just kind of break this down where it's at. Step one, we should be able to recognize that because of this negative 3, our principal axis, is going to be at y equals negative 3. So this thing oscillates around y equals negative 3. The next thing we need to do is that looking at this tells me that 2 above it, because the amplitude is 2, it's going to hit its max, and 2 below it, at negative 5, it's going to hit its minimum. So this is y equals negative 1, and this is y equals negative 5. So we know that this thing is going to fit somewhere in between those two values. Just so we've got it here, in general, what we're looking at is this thing. If I have my max and my min, I'm going to go something like, going to hit my max, going to hit my min, going to hit my max, going to hit my min. Now, we have to deal with two things. First off, we have to deal with this phase shift. So the phase shift is on plus pi over 4. So that means that because this is a sine function, the plus is going to move me back pi over 4. So my first intersection with this is going to be at pi over 4, because the plus means move to the left, pi over 4. Now, we're going to have to deal with that 2 pi in just 1 second, or that 2 value in just 1 second, and that's where we're going to go next. Remember, the period is always 2 pi over whatever that b value is. So in this case, 2 pi over 2, which means that the period of this function is pi. So what that is saying is that if we started at 0 and I did my normal sine curve, I'd be back at the start at pi. That's what this whole game is about. So, but we know from this that we're actually starting at pi over 4. So what we're doing is we're starting at negative pi over 4 plus pi is going to be when I get back to this magic point here, this repetition point. So if I was to do that, I would end up with, what is that? Sorry. So this is 4 pi over 4. Sorry. 4 pi over 4 plus negative pi over 4 tells me that at 3 pi over 4, I am back to the start. So I'm just going to try to sketch that in. 3 pi over 4 is in between. So now that I know that this thing is going to repeat itself, so this thing is going to go through its entire, I'm going to sketch it in, it's going to go up and down and up, back down again by that point in time. That's what's key here, is recognizing where it gets back to that repetition point. So if we look at that, in pi, it's going to do that. So halfway between, if the period is pi over 4, then the way that this works is sorry, my period is 3 pi over 4 is where I'm going to end up at. But at my period, I'm going to be at pi over 2. So to find this magical point, I'm going to do pi over 2 minus pi over 4. Because again, this thing tells me that I'm pi over 4 behind the mark. So if I do that, I'd be at pi over 4 is where this thing is going to hit its minimum again. And then halfway between pi over 4 and negative pi over 4 is 0. So it's going to go up, and that's our maximum at 0, comma, negative 1. It's going to come back down, and then at pi over 2, it's going to be at its minimum again, and at pi over 2, negative 5. So we get the first period of this thing done just like that. Now we could go further on, but the key thing is the shift pushes us back. Then we deal with our period after we've already traced in our upper and lower bounds. I hope that makes sense. Let's look at the next one and see if we can kind of consolidate what's going on with that. Okay, so just again, so we get this, plus 1. That means that I need to draw in a line at plus 1. So that's my principal axis is at y equals 1. Now the next bit, let me do that with a different color, I apologize. My next bit, let's look at this, and that means that my upper bound is going to be 4, because that's my principal axis plus the a value, which is 1 plus 3, which is 4. So that's y equals 4. Down here, if I get my minimum, that's going to be my principal axis minus the a value, which is 1 minus 3, which gives us y equals negative 2. So just with that, I've got my max and my min. Now I have to deal with this idea of what my phase shift is. So this is a cosine function. Cosine functions always start at the max, they go to the min, and they come back up. So cosine functions start at the max, but this says that my cosine function starts at negative 45 degrees. We go back 45 degrees. We good with that? So if I go back 45 degrees, then the place where this starts, and I guess I'm going to do this in pink, is, let's say this is negative 45 degrees. So to draw this, I start at the positive there. Now I got to figure out when am I going to get back to the maximum. And getting back to the maximum is going to be when this situation happens. So we just got to figure out what the period is. And the period is 2 pi over b. And if I do that, I would get 2 pi over 2, which is pi. So it takes me pi radians, or I guess we can write this as 180 degrees, to get back there. So where am I going to be back at where I started? Well, if I start at negative 45 and I add 180 degrees, I should be at 135 degrees positive. So 135 is going to be, now this is an estimate just due to the fact of the numbers we're dealing with. So what that means is this function, if I just sketch that out, it's going to start at a maximum at negative 45 degrees. And by the time it hits 135 degrees, it's going to have hit my minimum and come all the way back up. So this function is going to look something like that. And this minimum is going to be halfway between the maximums, between negative 45 and 135. So if I add those and I divide by 2, I'll have my minimum. So just real quick, doing that, adding that would give me 90, so we'll be at 45 degrees. So I'm going to draw my minimum in at about 45 degrees. And what I know now, just from those values, what I want from a sketch of this is it's going to come down, it's going to hit that minimum, and it's going to be right back up there. And then it would keep going on. But those are the key factors that we need from this. I think with that, with those two explanations, I think you'll be more than solid enough for tomorrow's assessment. I hope that's helpful.